Hi, welcome back to Troubleshooting Python Application Development. In this course, we're going to teach you how to figure out why your Python programs run fast or slow, and how much memory it is consuming, providing strategies for you to speed up your programs and also reduce its memory footprints when needed. We're entering a new section. In this section, we talk about Python idioms for faster code. And what that means is I'm going to show you 5 different ways that are built into Python where we can use to speed up our code. In this section, we're going to take a look at 5 strategies in Python that we can use to speed up our code. Number 1, we can reduce execution time and memory consumption with the slots keyword when we're creating objects. Number 2, we can use tuples instead of lists when our data doesn't change. Number 3, we can save a memory consumption with generators instead of lists. Number 4, I want to also talk about how we separate when to use lists instead of generators. And number 5, how we can leverage itertools to create generator pipelines. First things first, let's look at reducing execution time and memory consumption with slots. We're going to look at this in 3 steps. Number 1, what are slots? Number 2, how we can use slots. Number 3, inspecting the performance of slots versus class dictionaries. So this is what slots look like. In essence, you need to declare an internal variable in a class named __slots __. This follows the pattern of every other magic keyword when it comes to Python classes. What slots allows you to do is to specify to the Python interpreter what attributes you expect to be accessed and used in your class. As you can expect, because you're explicitly telling Python what are the attributes to cache, keep in memory, and not remove into garbage collection, you'll have number 1, faster attribute access, and number 2, reduced memory consumption. Let's test this out. Implementation-wise, we have a normal class foo. We're declaring some items for the slots magic keyword, and bear in mind that this is not a list, this is a tuple. So we have declared foo, bar, and bas 3 elements or 3 attributes within our tuple. Comparatively, we declare a class bar and simply put in no function body or class body. If we need to create a class with empty slots, i.e. it allows us to put in slots later on, or it allows us to subclass this class and still use slots later on, we need to create an empty slots value. To do that, we need to use an empty open bracket and close bracket to indicate that this is a tuple with no elements, and that's how we declare slots with no elements so that we can prepare for when some other class subclasses this class, it can still use the slots function. Let's take a look at performance. We create slotted, an instance of the slotted class foo. We create not slotted, an instance of the not slotted class bar. We have 2 functions. We have set delete slotted, which basically assigns a value to each of the attributes in slotted, where the attribute itself is in the slots magic keyword, and we then delete that value. We do the exact same thing with not slotted. We then use timeit.repeat to run these functions multiple times and prints out how long it took us to do. So I've just ran this, and let's take a look at the results. You can see that with the slotted version, overall we have less run times, so 38, 36, 33, versus the non-slotted version, which took about maybe 10, 15 milliseconds more. And that's all there is to it. Slots are a magic keyword which you can use to specify to Python which attributes in the class you expect to be used and accessed, and as a result, you can access these attributes faster, and overall your class occupies less memory if you're only using these attributes. We looked at creating classes using slots. What is, it's a magic keyword followed by the value of a tuple. And we inspected the performance of slots versus class dictionaries, or what happens when Python doesn't know what attributes you have and have to create a dictionary in the class to track your attributes, which is why it is slower and which is why it takes more memory.